534 test. Okay, on the test, this is what's on it. Are you ready? You will have 3 problems like this. Okay, you will have your review worksheet, not your review worksheet, you will have your formula sheet. On the formula sheet, I will give you the unit circle, and I will give you the formulas for the sum and the difference formulas for sine, cosine, and tangent. Yes? That's it. Unit circle and the sum and difference formulas for the sine, cosine, and tangent. Now, your goal. The cosine of 75 times the cosine of 35 plus the sine of 75 times the sine of 35. Yes? What do I expect you to do? I need you to go ahead and add those together or figure out which formula it is. In this case, it is going to be subtracting them. So this is the cosine of u minus v. So this is u and this is v. So this is the cosine of 75 minus 35.
40.
Thank you, ma'am. Appreciate it. What is 75 minus 35?
40.
The cosine of 40. Yes? Do we understand that? Are we good? Now, you are going to have to evaluate it also on the quiz or on the test tomorrow. And that means that my expectations are for you to actually give me the answer as well. I've lost it. A lot of kids forget it, so I changed my directions so that afterwards you can just give me the sine, cosine, or tangent. Now I'm going to tell you straight up, they're all on the unit circle. This is delayed. Yes, this is all on the unit circle. So whenever I tell you to evaluate, all you have to do is look at that value off the unit circle and give it to me. Yes? So let's say it's the cosine is 60 degrees. What is 60 degrees? Cosine of that is the x value, which would be 1/2. Yes?
So it's not going to be like that.
It will not be 40. Sorry. Yes. Okay?
So does that mean it won't be like the weird decimals like it was in math?
Correct. It will not be like that. Okay, you have 3 of these. Okay? Next, I give you the tangent of 85 plus the tangent of 15. Well, what formula is that? If I have plus and then on the bottom I have minus, that's going to be the sum. So that is going to be the tangent of u plus v. What is u? 85. What is v? 15. So that's the tangent of 100. Now on the test, I will give you a problem that is actually on the unit circle, and then you will give me the tangent of that value. Yes?
Yep.
3 of them. Yes?
Yep.
Next. Express each of the following as a sum or difference in terms of sine, cosine, or tangent and evaluate. Check the answer on the calculator to confirm you are right. None of these should be wrong because every time you should be able to check it on the graphing calculator or on Desmos, yes? So I'm telling you that you will have a cosine, a sine, and a tangent. You do not have to do the cosine of 195, the sine of 195, and the tangent of 195. No. I'm going to give you one problem. That's cosine. One problem, that is the sine, and one problem, that is the tangent. You know how on your homework I made you do all 3 of them for 4 problems each? You're not going to have that. I'm going to give you 3 different problems, and you're going to have either sine, cosine, or tangent of them. So you have to come up with the 2 numbers that are going to add or subtract to give you 195. Can anybody just tell me what that's going to be?
135 and 60.
Sure. I would love to know what I do with my notes. So this is going to be the cosine of, what did you say?
135 and 60.
Very good. Yes?
Are you going to find stuff that's on the unit?
You have to find the parts that are on the unit circle to be able to do this. That is not the only answer, okay? You could have done, let's say, another example would have been the cosine of 225 minus 30. That would work as well. It's, does your brain prefer adding or does your brain prefer subtracting? Okay? Does that make sense? So now I'm going to apply the cosine one. So if I'm applying the sum of cosines, that means I'm going to have the cosine of 135 times the cosine of 60, then it's minus the sine of 135 times the sine of 60. Yes? So now we're going to look at our unit circle, and we're going to literally pull those values straight off the unit circle. Yes? So what is the sine of 135? The sine of 135 is going to be your y value, so that's going to be the square root of 2 over 2. Yes? What is the cosine?
You just did sine for.
Negative. I wanted the cosine of 135, thank you. So that's negative square root of 2 over 2. The cosine is going to be 1/2. The sine is the square root of 2 over 2. And then the sine of 60 is going to be the square root of 3 over 2. Yes? Multiply them. Negative square root of 2 over 4. This is the common mistake. Don't make that mistake on the test tomorrow. Minus the square root of 6 over 4. And what is that going to give me? Negative square root of 2 minus the square root of 6 over 4. This is really slow today. Yes?
Sometimes these are just changing in the signs. You always get square root of 2, 6, and 4.
Generally speaking, those are the numbers you're going to get, but not always, so be very careful, especially if it's tangent. Yes? So there's the cosine. Are we good? Now I'm going to do a tangent. Now, the tangent I gave you is 11 pi over 12. Your brain probably doesn't think in radians, so what can you do to make this easier for yourself? Switch it to degrees. How do I convert this to degrees? Multiply this by 180 over pi. So the pi's cancel out. I'm going to come over here. I'm going to use Desmos, and I'm going to type this in, and I'm going to have 11 times 180 divided by 12, and that gives me 165. Yes? So now I'm doing the tangent of 165. So again, you are going to look on the unit circle for two angles that are going to add to 165 or subtract to 165.
135 and 30.
135 and 30. That works for me. So this is the tangent of 135 plus 30. So now we are going to apply the tangent of the sum of tangents formula. So that is going to be the tangent of 135 plus the tangent of 30. All over 1 minus the tangent of 135 times the tangent of 30. Now, when you are doing tangents or cotangents, I need you to stay away from your horizontal and vertical axis. And the reason why is, can I have a tangent that is undefined? Can I have a tangent of undefined where my y value over my x value, x is 0? You cannot use a tangent of a value that is undefined because I cannot do calculations with something that's undefined. Do we all understand that? So you have to stay away from your horizontal or vertical axis when you do these problems. Use other numbers, okay? So from here, I'm going to say, okay, remember I told you to write on here that the tangent, come on, of 60 is the square root of 3. The tangent of 45 is going to be 1. And the tangent of 30 is going to be 1 over the square root of 3. Yes? Okay? So now we know what those are. So now I'm going to be like, okay, well 135 is the denominator of 4 and 30 is the denominator of 6. So now we know what we're dealing with. So what is the tangent of 135? Well, that's a 45 degree. It's 1, but in this case it's going to be -1 because in quadrant 2, tangent is negative. So this is -1 plus, and what is the tangent of 30? That's 1 over the square root of 3, all over 1 minus a -1 times 1 over the square root of 3. Yes? Now, we did a bunch of these problems, did we not? I'm not going to finish this because I have many of the other equation problems that I want you to finish. This is calculational work at this point. Would you agree?
Do you want us to still rationalize it?
Oh, you absolutely have to rationalize every one of these denominators, okay? If you don't want to have an ugly problem like this, don't use the 30-degree angle ones. Why do you not want to use the 30-degree angle ones? Because it's 1 over the square root of 3. Try to use your 60 degrees, because that's just the square root of 3. Does that make sense? Okay? All right, that brings us to the next section. So that's all of 5-4. Are there any questions over 5-4 now? Now, 5-3. 5-3 is probably where things went south for some of you. So let's talk about 5-3.
Okay, I'm closing the door.
5-3. There are 2 sets of directions on your test, and you will have 4 problems in each of them. You will have 4 problems. You will have 4 problems where it says give all the possible answers. This means using 2 pi k or pi k. Okay? Or pi k.
What's the difference?
2 pi is whenever you have one revolution and you only want that quadrant, that same quadrant every single time. Pi k is whenever you want the one quadrant that you're in and then the diagonal quadrant as
So
well.
like if you get negative 1 over
So I'll give you an example, okay? So here we go. I give you 3 tangent squared of x minus 1 times the tangent squared of x minus 3. It's already factored. So set each parenthesis equal to 0 and solve. Yes? So from here, I have 3 tan squared of x minus 1, so that means the tangent squared of x is equal to 1/3. Yes? How do I get rid of the power? Take the square root. When you take the square root, you automatically are going to get the tangent of x is equal to 1/3, and the tangent of x is equal to negative 1/3. Do you see that? Yes or no? Plus or minus? Do we see that? Yeah? Okay, so I need to find on the unit circle where I have a positive tangent and a negative tangent of 1/3. Yes? Square root. My bad. Square root. Yes? Do we see that? Okay? Now, with that being said, tangent is going to be negative, positive, positive, and then negative there. Do we see that? Okay? Now, I need to have a tangent being 1 over the square root of 3. That means that I am looking at, erasing these, I am looking at this angle, and that has a positive, and this angle has a positive, this has a negative, and this angle has a negative. Why am I highlighting the wrong ones? That's bad. This angle is going to be a negative tangent. This angle is going to be a negative tangent. This angle is going to be a positive tangent. Those are your 4 answers. But here's the deal. If I am at pi over 6, and I add pi units to that, where does... All right, so if I'm at pi over 6 and I add pi units to it, that's a semicircle. Do you see where that's going to land me? At 7 pi over 6. This one is positive and this isn't positive. So by adding pi units, I'll get both quadrants. Do we see that? If I am over here at 5 pi over 6 and I add a semicircle to that, where does that land me? At 11 pi over 6. Does that give me all of my angles then? Absolutely. So your answer here is going to be x is equal to pi over 6 plus pi k, and what was the other one? 5 pi over 6.
Oh my lord, I'm having a stroke.
Plus pi k. Do we understand this side?
I'm sorry, where did you get the pi k from?
Because if we add the semicircle, the half of it, that's pi. So whenever I'm at pi over 6 and I add the semicircle, it gives me 7 pi over 6. Agreed?
Yeah, so you're just marking that down as...
Correct. So instead of adding 2 pi to 4 times, to 4 different angles to land there every single time, if I'm here and I add pi, I'm there. If I add pi, I land here. If I'm add pi, I'm over here. So you're adding semicircles to get to the other quadrants. Okay?
I wasn't able to hear.
Okay, so let's do this one over here. Tangent squared minus 3. So I'm going to go ahead and add the 3 over, take the square root, and I'm going to get that the tangent of x is equal to plus or minus positive square roots of 3 and negative square roots of 3. Okay, well now let's rethink this through. Okay? If we're thinking this through, what this means is now we have to say, okay, well, where's the square roots of 3? When do I have tangents of the square root of 3?
60 degrees.
60 degrees. So I'm looking for all the ones that are 60 degrees. Well, the ones that are 60 degrees are going to be where? Right here. So I'm going to be at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay, but again, remember, we need to think in semicircles. So if I am right here at pi over 3 and I add a semicircle to that, that puts me at 4 pi over 3, right?
Yeah.
If I go to quad 2 and I start at 2 pi over 3 and I add a semicircle to that, where does that land me at? 5 pi over 3. Does that make sense? So those two answers that I'm going to use are going to be pi over 3 plus pi k and 2 pi over 3 plus pi k. Yes? Do we see that?
Yeah.
So now those are the 4 answers that I expect to find on your test tomorrow if you would have a problem like this. Okay? Next, 4 cosine squared of x minus 1. Don't overthink this. So how would I solve this?
Send the 1 to the other side.
So I have 4 cosine squared of x is equal to 1. Cosine squared of x is equal to 1/4. Square root it. So the cosine of x is equal to 1/2, and the cosine of x is equal to negative 1/2. Do we see that? There's 2, positive plus or minus, right? Okay? Because you have to add that plus minus there. Okay? So we're looking on the unit circle for when I have a positive 1/2 and a negative 1/2 for my cosine. Well, where's that going to be? 60 degrees. Positive. How about here? 2 pi over 3 for the negative. How about over here? 4 pi over 3, which gives me a negative 1/2. And then 5 pi over 3, which gives me a positive 1/2. So how do I get these answers? What's going to be my final answer? My final answer is going to be this plus pi and this plus pi. Would you agree? And that's going to give me all of my answers. So x is equal to pi over 3 plus pi k, and x is equal to 2 pi over 3 plus pi k. These are my only 2 answers that satisfy both of those.
I like it.
Does that make sense? Yes? You have 4 of them on the test tomorrow. Yeah?
Yeah.
Okay, now let's keep going. This time the directions change and it says I want it just on the interval between 0 and 2 pi. No pi k, no 2 pi k. Do we all understand that? Yes?
You gotta find them all.
You got to find them all, just between 0 and 2 pi. So how do I solve this problem?
Send the 1 to the other side.
I would not send the 1 to the other side. Factor into 2 binomials. Make sense?
Yeah.
So this is going to be 2 cosine of x and cosine of x. How do I break up 1? Positive 1 and negative 1. I need to have a positive cosine. So what goes in my first parenthesis?
Minus.
And my second parenthesis, plus. So now I have 2 cosine of x minus 1 is equal to 0. So 2 cosine of x is equal to 1. So cosine of x is equal to 1/2. So my directions say from 0 to 2 pi. So all right, what angles have a cosine of 1/2? Positive cosine of 1/2. So pi over 3 and 5 pi over 3. Those are the only 2 angles on the unit circle between 0 and 2 pi that have a cosine of positive 1/2. So I come back over here and I'm going to say that x is equal to pi over 3 and 5 pi over 3. Does that make sense, yes or no? Okay, come over here and do the other parenthesis. Cosine of x plus 1 is equal to 0. Cosine of x is equal to negative 1. Where on my unit circle is cosine equal to negative 1? at pi. So I come over here and I simply say x is equal to pi, and those are my 3 answers that I expect you to have on the test. Does that make sense?
Yes.
Yeah? Okay, what about this one? What do I do here?
Sine, cosine, terms of sine, cosine.
No, thank you.
Bring the two cosecant over.
Set it equal to x, so make this the secant of x times the cosecant of x minus 2 cosecant of x is equal to 0. Now what? Pull out of the GCF. And what is the GCF? What do we say the GCF is? Careful. Cosecant. So I'm going to pull out the cosecant of x, and what remains is what?
Secant x
Minus 2 is equal to 0. Yes? Okay, so what do I do from there?
cosecant of x is 0 and secant of x minus 2.
Cosecant of x is equal to 0, and the secant of x minus 2 is equal to 0. Okay, did I memorize cosecant on my unit circle anywhere?
Now,
No. So I need to put this into my brain as to what's on my unit circle. What's on my unit circle are sine and cosines and tangents. So what is the reciprocal function of cosecant? That's what it's equivalent to, but I asked what was the reciprocal function. So the reciprocal function is the sine of x. So if cosecant is equal to 0, the reciprocal of that is sine, so what is the reciprocal of 0? 1 over 0. What is 1 over 0?
Undefined.
Undefined. Undefined. So where on the unit circle is my sine value undefined?
90.
It's undefined?
Sorry, no.
Okay, let's one more time ask this question. Where is my sine, which is my y value, undefined?
never.
Never. Never is my sine value undefined. Not on that. So therefore, this means that this is no solution on that side.
When you pulled out the GCF up top, are you treating the secant x times cosecant x as one term?
Uh-huh.
Yeah.
Okay, now, how do I do the secant of x minus 2?
Add 2 over.
Add the 2 over. Killing me. Now, did I memorize secant?
No.
Now.
So what is the reciprocal function of secant? Cosine. And what is the reciprocal of 2?
1 over 2.
Okay, so now we're coming back to our unit circle and we're saying, where is my cosine positive 1/2?
Positively
At 60 and
down there. I can't.
at 5 pi over 3. So I have pi over 3 and 5 pi over 3.
Again?
Yep.
Man.
Does that make sense?
Yes.
You have 4 problems like this tomorrow on the test.
Wait, that's the 4 plus
It's a big
4
Not really.
plus 3.
So let's review one more time as to what's on the test.
That's one.
You have 3 problems like this. You have 3 problems like this. One's a sine, one's a cosine, one's a tangent. So that gives me 6. Then you are going to have 4 problems where you have to give me 2 pi k or pi k. So what's that put me at so far?
10.
10. And then you are going to have 4 more problems where it's just between 0 and 2 pi.
14.
So you have 14 problems on the test tomorrow.
That's a big one.
Is there any questions as to what my expectations are? I'm going to be straight up honest. I took problems off of your Math Excel and put them on the test.
Even the easy ones? Well, that's a lot. Big
Yeah.
test.
I have a question like overall.
Okay. Are we good on the review part?
Yeah.
Okay, test tomorrow.